Let's find a general solution using separation of variable for these two differential equations. The first problem, we have e to the y minus 1 times y prime equals to e plus cosine x. So looks like all the y's on one side, all the x on the other side. So this should be a simple problem. So we have e to the y minus 1 and then change the y prime to dy dx. That is the derivative of y with respect to x. And then on the other side, no change. And then I would like to multiply the dx to the other side. So all you have to do is you multiply dx on both sides. And then you have e to the y minus 1. And then dy equals to 2 plus cosine x. And then this whole thing multiply dx. So the separation of variable is done. And then you can take the integral on both sides because now we have all the y's on the left and then all the x on the right. So we have integral. The integral of e to the y is still e to the y. And then the integral of 1 is equals to y. The integral of 2 is 2x. The integral of cosine is equals to sine. So plus sine x, and then we stick a plus c to the x side. And then this one, can we have one y on one side? The answer is no, because there is no way to take the y out of the e and then without changing the other y. So this one, I will just take this as the final step. I will box this line and then add one more thing to it. I will say cannot solve explicitly for y. So we cannot solve explicitly for y. And then that's it for the first problem. So moving on to the next one. The next one, we have d theta dt equals to t times secant theta divided by theta times e to the t square. Okay, I would like to have t on the right and then theta on the left. So that means let's split up the t and the theta first. So we have d theta dt. So the first step is let's have one fraction that contains all the theta. So I will do a secant theta divided by theta and then multiply t divided by e to the t square. And then t on the right. Okay, so I will do d theta, just multiply dt on both sides. So the dt will move to the right. So we have that equals to secant theta divided by theta and then t square et square dt. Okay, so now all the t is on the right hand side, and then to move the theta to the left hand side, you have to multiply both sides by theta over secant theta. So after you move this to the left hand side, you will get a reciprocal. So should be a simple algebra for calculus students. So theta divided by secant theta d theta equals to t divided by et square dt. And then this one there is an integration by parts on the left side. There is a u substitution on the right hand side. So to perform the integration by parts on the right hand side, do you still remember this? You have let's use this color for better contrast. You have secant theta, right, equals to 1 divided by cosine theta. If you have 1 divided by secant theta, then you have 1 divided by 1 over cosine theta. Then you get a cosine of theta. So on the left hand side, you have theta times cosine theta d theta. On the right hand side, you have a let's use negative exponent t e to the negative t square. So we bring the e to the numerator and then dt. So the separation of variable is done. So now the separation of variable is finished, and then we are now ready to integrate. So let's draw integration symbol. So integrate. So on the left hand side, we have an integration by parts. So, and then on the right hand side, we have a u substitution. So if you like color codings like I do, I will just use different color for each work. So this is integration by parts. So let's do the by parts on the left side since we have some space under the blue. So we have to let u equals to theta. So du is equals to d theta, and then the dv is equals to cosine, and then d theta, and then v is equals to integral of cosine is equals to sine. So sine, integral of cosine theta d theta, that is equals to sine theta, right? And then you have uv minus the integral of v du. This is the formula for integration by parts. So we have theta times sine of theta. So we have theta times sine of theta minus the integral of sine theta d theta. The answer is equals to theta times sine theta minus, and then the integral of sine is equals to cosine, negative cosine theta, right? And then since you have a minus minus, then the minus, this minus for the integration by parts becomes a plus. So we can go ahead and erase the two minuses and then draw a plus right here. So this is part of the solutions. Alright, so the by part is finished. What about the other side? The other side is a U substitution. So let's use another color to do it. So this is a U substitution. And then since the E is a composition function, I'm going to let U equals to negative t squared. So du is equals to negative 2t dt, and then 1 divided by negative 2t du is equals to dt, and then we will do a change of variable. I will change this dt to this, and then we have integral t times e to the u, and then the dt is 1 divided by negative 2t dt, and then of course you will be get the du, because in the red box there is a du, and then we cancel the t, so we only have a u left. So the integral of eu is still e to the u, so we have negative 1/2 and then still e to the u, right? And then still e to the u, and then we plus c. So since this was in t, so what let's put the t back to the u. So what was t equals to? That is negative t squared. So this is the other part. So we have the sine on the left side and then the negative 1/2 on the right hand side. Okay, so let's bring the two pieces together. So finally, after doing all the hard works, we have theta times sine of theta plus cosine of theta. So that is the job on the left hand side, equals to this one, the t, you can bring it down. You can do this. You can do 1 divided by 2 e to the 2 square, and then plus c, or you can just lift that up. But if your instructor doesn't like negative exponent in the final answer, then you have to bring it down to the denominator. So this one, there is no way to bring the theta, to let the theta stand itself. So I will end right here and then add one more thing to it. So that is, cannot solve explicitly for theta. So cannot solve explicitly for theta. So that means I am not able to put one theta on one side and then you have a bunch of t on the other side. Okay, so that is the end of this video. If you think my instruction is helpful and clear, give me a thumbs up, click the like, share the video for me. If you're on your way out, subscribe to my channel. I will catch you all in the next lesson. Signing out.